Hi, I'm Matt Souva, and I'd like to tell you a little story about polymer nanoparticles. Nanotech is more than just a buzzword. Functional nanoparticles hold a lot of promise if we can find the right way to use them. So let's take a bio example. Semiconductor quantum dots could be the next great fluorescent agent for cell labeling. Iron oxide particles could be the next great magnetic material for MRI. Chemotherapeutics could answer a lot of issues in cancer treatment, but there's a problem. Many of the most promising nanoparticles are made using organic synthesis, and they're hydrophobic. They hate water. That's not great for bio. Taking that promising cancer drug, putting it in the bloodstream, it'll aggregate up before it goes anywhere. So what do? Well, one answer is the work done in my group. We take functional nanoparticles and encapsulate them in polymer nanoparticles. So our polymer nanoparticles are made of block copolymers. One part is hydrophobic, the other part attached to it is hydrophilic. It likes water. That dual nature is important because it means we can induce self-assembly. So let's start with our block copolymer dissolved in an organic solvent. Then we introduce them to water and they self-assemble into these structures that have hydrophobic cores protected from water by the hydrophilic exterior. You remember those functional nanoparticles? We can stick those in the same organic solution. Normally, when they see water, they clump up, but here, they'll go to the core of these structures where they're protected. So now we have 30 to 90 nanometer spheres that are water soluble that contain our functional material. And it works. The quantum dots still fluoresce, iron oxide is still magnetic. The chemotherapeutics, we've loaded those and studied their release profile. It's very promising. But that's not the whole story, because most of the work done so far has been on a batch scale, benchtop stuff, which is fine, it works. But what if you need more? What if you need to label a tumor? What if you need to treat an actual patient? You need more material, you need to make it more efficiently. Batch by batch method's not the answer. So the rest of my research is in exploring scalable flow-based methods for producing polymer nanoparticles. They're ways of introducing the organic to the aqueous efficiently. One is a spray method, we spray out organic droplets. The other is a mixer method where we directly introduce the water and the organic. Because in this research, both sides matter. We want to use these functional nanoparticles, so we need to protect them. But if we're going to make enough, we need to find a different way. So we need to understand the properties of these materials on the nanoscale, but we also have to remember that for this to matter at all, we have to get to work on the macro scale. Thanks.